Okay. Hello everybody, thank you for stopping in, and here is my digital tutorial question. Today we'll be looking at calculating the percentage change in a given energy level of a particle in a 3D cubic box when the length of the edge of the cube is decreased by 10% in every direction. This will be a straightforward question that will involve a little bit of simplification and then at the end a bit of algebraic manipulation, and we will arrive to our solution. Right off the bat, we have our energy equation right here of a particle in a three-dimensional box, and we are dealing with length, only length. We will be manipulating that, changing that. In our case, we will be decreasing that. Therefore, these values right here that I'm circling, h, Planck's constant, 8 mass, and the energy levels, we won't be dealing with it. We could simplify it to a constant. Therefore, our initial energy level that we'll be looking at would be E initial equals C over L squared. And now what will be our final length? Really straightforward. Let's say our initial length is 1.0, and if we decrease it by 10%, we'll E initial equals 1, subtract by 10% would be 0.1 equals 0.9. Therefore, that we know L final, our final length, equals C over 0.9 L squared. Simple as that. And now we want to find the change in energy level. Therefore, delta E equals E final, subtract E initial. Now we are going to plug our two lengths, the final length and the initial length, into up here. Simple, straightforward, would be C over 0.9 L squared minus C over L squared. And now looking at the function, we could do some simple simplification by factoring out C over L squared. Now we will end up with 1 divided by 0.9 squared, subtract 1. And now we want to do the final part of the problem, which involves finding the percentage change. Therefore, delta E over E would be our percentage change. And now we plug and solve. We will have C over L squared. And now by that guy, 1 over 0.9 squared, subtract 1. And then now we're going to divide that by our E level. C over L squared, our initial E energy level. And right there, we could cancel out some terms. Boom, pow. And now we will simply end up with 1 over 0.9 squared, subtract 1. And if you do the math, plug it in, do whatever you want, we will end up with 0.235. Now, to find the percent, multiply that by 800, and we will simply end up with 23.5%. So when we have a particle in a three-dimensional cubic box and we decrease the length of the edge by 10% in every direction, we will get an overall energy change